Hello, I'm Frank Sousa.
And I'm Robert Vriesman. 8 years ago this week, Homework Hotline first went on the air. And every day this week, we're taking a look back at our first 7 years. Today, we're going to share some of our most embarrassing moments.
That's right, our bloopers. But first, the opening titles from the 5th season of Homework Hotline. Don't go away. Hello, welcome back to the math segment of Homework Hotline. I'm Frank Sousa.
And I'm still Robert Vriesman. We're here for the math segment of Homework Hotline. But before we get started, let's go to one of our English teachers, Mariel Suarez, at the phones and just see what kind of calls are coming in right now. Mariel?
Thank you still, Robert. And as you can hear, the phones are getting busy today. We've got 15 lines and 15 dialer teachers to take your calls, so call now. And if you have an English question, call Ask for Me. Maybe we can do your problem live on the air. English comes on at 5 o'clock, so stay tuned now for 30 minutes of math with Frank and Robert.
Remember, you can call in your questions simply by calling 1-800-527-8839.
Or if you have trouble remembering numbers, just dial 1-800-LA-STUDY. The call is free, the help is free, so what are you waiting for?
Well, we're waiting for this. This is something special today. We have a special treat. As regular viewers of Homework Hotline know, each one of our shows flows perfectly, from the opening titles to the goodbye. We never make a mistake.
Not.
True enough. And over the years, we've shared some of our finest moments on videotape. So, roll them, John.
Our Emmy-nominated Homework Hotline show will be on in just a minute. Our lines are open, so give us a call at 1-800-LA-STUDY. We're all set to help you with your English and math homework, and we've got some problems.
Our phone number here at the studio is 1-800-LA-STUDY, or you can dial the number simply by dialing 1-800 and the numbers that go with LA Study.
Hi, I'm Ellen Stonehill. Homework Hotline will be on in just a minute. Our lines are now open, so phone us in with your English and math questions. Call us at 1-800-LA-STUDY. We're all set to help you with math and English. So now let's begin the show.
It's time for me to wrap up math, but stay tuned for 30 minutes of English, and Steve and Ellen are waiting to teach you something. Bye.
12 into 21. How many times will that go?
12 times 1.
Well, happy April Fools.
April Fools, Mrs. Stonehill.
All right. To continue, why did this happen to me? Why didn't this happen to one of the math people?
But that's all I have, and I'd like to donate the remainder of my time to a fine math teacher, in fact, the teacher of the year for Los Angeles City Schools, Mr. Ira Moscow. Thanks, Ira. Does that answer your question?
That answers it, and that's really interesting. I never knew a lot of this stuff. Which really goes to show you that whether you're a teacher or anybody, there's still plenty of stuff that you can learn. By the way, if you enjoyed watching Hall Davidson, you know, you can watch him on the mornings. It's from 7:30 to 8 o'clock on this same channel, channel 58, doing more math. And it's so if you ever can't go to school someday or you're ill, turn on channel 58, watch Hall, then you'll probably really be ill.
You dogs, you dogs, you dogs, dogs, dog.
He's phenomenal. You better. For that time he made me laugh so much. Do you remember when he was in the back? He has to be punished. He was wicked. Hello, this is Ellen Stonehill, and I'm just here to remind you that in 1 minute, Homework Hotline will be on the air. This is a special awards edition in honor of the Academy Awards, and we really hope that you're going to stay tuned because we have wonderful questions in math and English. So please stay tuned, and I don't know what those jerks are doing behind me, but I... Goodbye!
We're coming to you live, and for the next 40 minutes, we're going to be answering your questions about mathematics. If you have any questions, you're welcome to call us at 1-800-LA-STUDY, and you can call anytime between 3:30 and 6 p.m. Monday through Thursday. Remember our phone number here at the studio is 1-800-527-8839, or just simply dial 1-800-LA-STUDY. Hi, I'm Steve Ward.
And I'm Ellen Stonehill.
Oh my goodness, Ellen. Homework Hotline will be on in just a minute, and our lines are now open, so give us a call at 1-800-LA-STUDY. We're all set to help you with your math and English homework, and we have some very interesting problems to cover today, so stay tuned. Ellen Stonehill, I'm going to get you.
Remember, you can call between 3:30 and 6 o'clock Monday through Thursday. The number is 1-800-500-88... That's wrong. 1-800-LA-STUDY will be easier. I couldn't see it. We'll see you tomorrow at 4:30, and I'm Ellen Stonehill, and this is Homework Hotline.
I hope you enjoyed those. Well, Frank, what are you going to do today?
Well, I have a caller that's going to help me solve a problem involving polynomials. Then I'll be doing a geometry problem involving the Pythagorean theorem. And then working with some rational expressions. How about you, Robert?
Oh, sounds great. I have a terrific complex fraction that we're going to work out, and I have some help with it as well. And then I have some radicals and a couple simple equations.
Okay, let's get started.
Time to get going.
Okay, I think I have a caller on the line. Sandra, are you there?
Yes.
Hello, Sandra?
Yes.
Okay, we're going to work on this problem. Before we get started, Sandra, can you tell us what grade you're in and what school you go to?
I'm in 10th grade and I go to Birmingham High.
Hello, I'm Doris Johnson Humphrey.
And I'm Wilfred Smith. 8 years ago this week, Homework Hotline first went on the air, and every day this week we're taking a look back at our first 7 years. Today, we have a special live guest. And later in the show, we'll look at some of the original audition tapes for Homework Hotline. But first, our producer's favorite opening title sequence. This one is from the second season.
May I help you?
Well, I'm sitting in the classroom, it's 1:45. Teacher's giving an assignment, telling when it's due. So I hurry on home, I know I'm not alone. I open up my book and I go and grab that phone. I'm calling Homework Hotline, I'm calling Homework Hotline.
Good afternoon and welcome to Homework Hotline. I'm Doris Johnson Humphrey.
And I'm Wilfred Smith. we're here for the math segment of Homework Hotline. But before we get started, let's go to one of our English teachers, Mario Suarez, at the phones and see what kinds of calls are coming in. Mario.
Thanks, Wilfred. I am Mario Suarez, and as you can hear, the phones are getting busy today. We've got 15 lines and 15 dialer teachers to take your calls. But now I'd like to introduce all of you to another one of our dialer teachers, Emilia Tinoco.
Hello, my name is Emilia Tinoco. I'm a kindergarten teacher at Euclid Avenue School in East Los Angeles. I can help you with any of your homework in history, English, social studies, or Spanish. Por favor, llámeme si necesitan ayuda con su trabajo de escuela. Estoy aquí para ayudarles con su tarea.
Thank you, Emilia. And she is a kindergarten teacher, and remember, as the twig is bent. Now remember, call and ask for me if you have an English question. Maybe we can do your problem live on the air. English comes on at 5 o'clock, but stay tuned now for 30 minutes of math with Doris and Wilfred.
Okay.
Remember, if you have a math question, you can call us by dialing 1-800-527-8839
or simply dial 1-800-LA-STUDY. The call is free, the help is free. So what are you waiting for? Now today, we're in the second day of our week-long 8th anniversary celebration. And we're very pleased to have a special guest with us today.
He's the teacher with the distinction of having said the first line of dialogue on the first ever Homework Hotline. Here's an introductory clip.
All right, we have a live call-in also. And can I have your first name, please?
Oren?
All right, Oren, let me write your name on the board.
Okay.
Did I spell that correctly?
Yeah.
All right, can you tell me what your problem is, Oren?
Yeah. I have a cube here.
A cube. All right, let me draw a cube on the board for you, okay?
Okay.
Now, I'm not a very good artist, Oren, so don't laugh at my cube if it doesn't look exactly like the one does in the book, okay?
Okay.
And today, we'd like to introduce our very special guest. Mr. Moscow, would you come over here, please?
Good to see you, Mr.
Good
Smith.
to see you.
Doris.
Great having you here.
And it's good to be back.
I understand you have a live call today?
I think so.
Great.
Hippolito, are you on the phone?
Yes, I am.
Okay, Hippolito, can you tell me what your question is?
Yes, my teacher says that we have to do problems without calculators.
Okay, without calculators, yes.
And we have to do them mentally.
Then, okay.
The problem is parentheses,
Parentheses.
7867, parentheses,
All right, 7,867.
parentheses,
Right.
okay, parentheses, 7, comma, 8, 6, 7.
Okay, 7,867 times 7,867.
Okay, minus,
Ah, there's more, okay.
parentheses, 7, 8, 6, 4, parentheses,
Okay.
parentheses, 7, 8, 7, 0.
Okay, now your teacher said you have to do this without a calculator. You have to do it mentally. And, wow, that looks like a kind of difficult problem. Let me ask you a question, Hippolito. What math class are you in right now?
Well, right now I'm in algebra.
Algebra. Okay, have you worked with multiplying polynomials yet?
Yes, I have.
Okay, the only way we can do this problem real quickly is as follows. Pay attention as I do this, okay?
Okay.
Why don't we let 7,867 equal x, okay?
Okay.
Let me just write that down. X is going to equal 7,867. Now, tell me how I can represent 7,867 times 7,867. How could I represent that if this is x?
You could represent it as x squared.
Right. This times this is the same as x times x. So let's rewrite this as x squared, okay?
Okay.
Now, we have our minus, so let's copy that down. And now, how does this number compare with x? 7,864, how does that compare with our x over here? Is this more than x, less than x? How does it compare?
It's less than x.
How many less than x?
3.
3. So I could rewrite this number as x minus 3. Do you see that?
Yes.
Okay. How can I represent this number now in terms of x?
X plus 3?
Exactly. This number right here is 3 more than x. So let me write that as x plus 3. Now, let's see how algebra is going to help us solve this rather complicated looking problem. Let me copy down this x squared, and now let's multiply these two binomials together. Could you tell me what you get when you multiply these?
You'd get x squared minus 9?
Right. It's called a difference of two squares, x minus 3, x plus 3. Okay, we're almost done, Hippolito. Let's distribute or take this minus sign through this parentheses. Copy down the x squared. Tell me what to write next. Minus.
Minus x squared.
Okay, and then?
Minus.
Well, we have actually a minus, a negative, so that turns into, pardon?
Positive 9.
I'm sorry?
Positive 9.
Positive 9, thank you very much. Now, one more step. X squared minus x squared, they just cancel out. And what's left, Hippolito?
Positive 9.
Positive 9. So we went ahead and solved this very complicated looking problem without even touching these numbers, just from using the algebra that you've learned in your algebra class. Does that help at all?
Yes.
Okay, thank you very much for calling, Hippolito.
Okay, thank you.
Okay.
Bye.
Goodbye. Okay, and I've just been informed that someone else is on the phone. Hello? Are you there? Is there someone on the phone?
Hello?
Hello? Can I have your name, please?
My name's Ayal.
Ayal, can you spell that for me?
E-Y-A-L.
Okay. And what school do you go to, Ayal?
I go to Beverly Vista.
Okay, very good. Beverly Vista. Now, I've been informed that you have a question having to do with solving an equation using the quadratic formula. Is that correct?
Yeah.
Okay, can you read me the question, please?
Okay. The equation is a squared.
A squared.
Over 4. Equals a minus 1.
Okay. Now, whenever you're solving a problem using the quadratic formula, by the way, let me write the quadratic formula down over on the side, okay?
Okay.
Do you know what it is? Do you know what the quadratic formula is, Ayal?
Yeah, I have it written down here.
Okay, can you read it to me?
X equals.
X equals.
All right, now there's a big fraction. It's negative b.
Okay.
Plus or minus.
Plus or minus.
The square root of b squared minus 4ac.
And is that all, or is there something else?
No, that's all over 2a.
Right. Now, for those who are wondering, gee, this looks awfully complicated, let me explain what each of these letters really represents. First of all, let's go back to our equation. When I have equations involving fractions, I like to multiply every term by my lowest common denominator because I don't like to work with fractions, and I'm allowed to multiply everything by the same constant and not change the equation at all. What is my lowest common denominator here, Ayal?
4.
4. So let me multiply every term by 4, okay?
Okay.
Multiply this by 4, and what do I get?
A squared.
Okay. And multiply every term here by 4, and tell me what I get.
4a minus 4.
Now, whenever you're using the quadratic formula, you should go ahead and get everything equal to 0. So let's go ahead and rewrite this so that everything is equal to 0. Can you do that for me?
Okay, a squared minus 4a plus 4.
Okay, equals 0. And now we can use our formula. The coefficient of a squared is what we call a. So what is the coefficient of a squared?
1.
1. And what's the coefficient of a? That's what we call our b. What is that?
4. Negative 4.
Negative 4. And c is our constant term, and what's that?
Positive 4.
Okay. Now, a is 1, b is negative 4, c is 4. We come over here and substitute in, and we'll end up with our solution. X is equal to the opposite of b. What's the opposite of b?
4.
4 plus or minus b squared is?
16.
16 minus 4ac. What does that turn out to be?
16.
16 all over 2a, and that becomes?
2.
Okay, let me do this quickly. 4 plus minus, this is the square root of 0 over 2. X is equal to 4 plus or minus 0. 0 doesn't change anything, so it's just 4 over 2, so x is equal to 2. Now, normally a quadratic equation has 2 solutions, but this is one of those that only has 1 solution, okay?
Okay.
Does that help you at all, Eyal?
Yeah, Mr.
All right,
Moscow?
yes.
You're a good man.
Okay, thank you very much, Eyal. Let me just I just have enough time for one real quick equation here. This was called in from John at Audubon. You want to solve this, which means you want to know what x is equal to. So you have to get rid of this minus 4. You know how we get rid of minus 4? Add 4. Okay, x minus 4, and we add 4. But you see this 11? It says, hey, buddy, if you added 4 to the left side, you've got to add 4 to the right side, too. Okay, 11. And so we take the 11 and we add 4 to him. What do we end up with? X is equal to 15, and that's it. I hope that helped you, John. And, you know, they're telling me that my time is up, but I really had a good time coming back and hope maybe they'll invite me back another time. Anyway, Mr. Smith, Doris, thank you very much.
You did welcome back, Noss.
Thank you. Thank you very much.
Eight years ago this week, Homework Hotline first went on the air. And every day this week, we'll take a look back at our first 7 years, learn a little about the show's history, and see some rare clips, bloopers even, and even our first opening title sequence. So, stay tuned.
The Los Angeles Unified School District presents Homework Hotline, a program designed to help junior high school students with math and English. Teachers are waiting for your questions. The lines are now open, so give us a call at area code 213-625-5358. And now, live from Channel 58, it's Homework Hotline.
Hello again. I'm Doris Johnson-Humphrey.
And I'm still Robert Vriesman. We are here for the math segment of Homework Hotline. But before we get started, let's go to one of our English teachers, Jose Hernandez, at the phones, and just see what kind of calls are coming in now. Jose, in just a minute, we're going to go right over to you, so you better hurry up over there, Jose. And ladies and gentlemen, here's Jose.
Thanks, Robert. Thanks, Doris. Well, as you can hear, the phones are lively. Today we've got about 15 lines and 15 dial-a teachers to take your calls. And I'd like to introduce you to one of those dial-a teachers. I'd like to introduce you to Mr. Bloom.
Thank you, Jose. Hello, everybody. My name is David Bloom, and I am a 5th and 6th grade teacher at Rockdale Elementary School in Eagle Rock. If you will call 1-800-LA-STUDY, I'll be happy to help you with all of your homework questions. And I see I have another call. Thank you.
Great. Thank you, Mr. Bloom. Well, if you have any English questions, please call and ask for me. Maybe we can do your problem live on the air. English comes in at 5, so stay tuned now for 30 minutes of math with Doris and Robert.
You can call in your math questions and English questions simply by calling 1-800-527-8839.
Or just dial 1-800-LA-STUDY. But before we go any farther than that, let's talk about what we're going to do today.
Okay, today I'm going to be dealing with simplifying radicals, completing the square, and hopefully working with polynomial fractions.
Great. I'm going to do a percent problem. It's a word problem, and I have some help with that. Then we have another problem that was called in by a student named Pythagoras. Does that name sound familiar?
Very familiar. Does he know about the theorem?
Yes, I think so. Well,
Okay,
he has some harebrained idea about a triangle, and we're going to see if it's going to work out.
See if it's going to work. Okay, great.
And also, I have an interesting quadratic, but hopefully I have time for that.
Great.
So this is an exciting week we have coming up here. This is our anniversary, and we want you to pick up that phone, go grab pencil and some paper, because this help is absolutely free. The call is absolutely free. Remember, it's 1-800-LA-STUDY. Doris, do you have anything to add to that?
Yes. What are you waiting for?
That's a good question, Doris.
Well, my first question was called in by Chrissy, and Chrissy is a 10th grader, and Chrissy and I are going to be simplifying a radical expression. Chrissy.
Huh?
How are you doing?
5.
Are you excited?
Not, well,
Get excited, Chrissy. You're on television.
Okay.
Okay, let's look at our problem. We have radical 3/4 plus radical 1/3 minus radical 1/5. Chrissy, first of all, what we're going to have to do. Chrissy, are you okay, dear?
Yeah, my friend.
Tell your friend don't play. This is business.
Play.
This is business, Chrissy.
This is business.
Thank you.
Okay.
Okay, Chrissy. What we're going to do is rationalize our denominators. In rationalizing denominators, what we're trying to do, Chrissy, is to get these denominators from under the radical sign, because one of the things you have to remember when simplifying radicals, you cannot leave a denominator under the radical sign, okay?
Uh-huh.
So first of all, can we do anything to this fraction?
Yeah.
What can we do?
Take the 4 out.
Take the 4 out,
That's
but
going to be, huh?
Go on, continue. I'm
It's gonna
sorry.
be radical 3/2.
Radical 3/2. So what you did, we didn't have to rationalize that denominator because 4 is already a rational number. When I talk about rationalizing denominators, Chrissy, and rational numbers, a rational number, you can take the square root of a rational number. And so 4 is a rational number. You took the square root of that for us and told us that it was 2. So we are finished with that fraction for now. What about 1/3? What can we do with that?
Multiply it by radical 3.
Okay, and if we multiply, let me separate this and write it like this. It's the same term. So I'm putting radical 1 over radical 3, which is the same expression. And you said we're going to multiply this by radical 3. We do the same thing to the numerator and the denominator, okay? Let me put this in parentheses so it doesn't get confused. Okay, what are we going to do with this term, Chrissy?
Multiply by radical 5.
Okay, and what happens when we multiply the numerator and the denominator by radical 5?
What happened?
Yes. What we're doing again, Chrissy, is something that's called rationalize the denominator, which means make it a rational number so we can take the square root of it, okay? So I'm going to do what you said. I'm going to write this square root of 1 over the square root of 5. Remember, I'm writing it this way, but it's the same expression. You told me to multiply it by radical 5. And whenever we multiply, we do the numerator and the denominator. And let me put this in parentheses so we won't get confused. We still don't have anything to do with this fraction yet, so we're going to bring it down. And I want you to walk me through what's going to happen in this first set of parentheses. What's going to happen?
It's going to be 3 over...
Radical 1 times...
radical 3 is 3.
No.
Radical 3.
Radical 3, right. Because when you multiply 2 radicals, you're going to get a radical product unless you have a rational number. Okay, what happens in the denominator, which is real important?
They multiply it to each other.
Okay, radical 3 times radical 3 gives us what? What does it give us?
3.
3. It comes out of the radical sign because when you multiplied radical 3 times radical 3, you got radical 9, right? And the square root of 9 is?
3.
3. So we've rationalized that denominator by making it into a rational number and taking the square root of it. Okay, now, simplify what's in this parenthesis.
The top is going to be radical 5.
Great, radical 5. And what is the denominator going to be?
5.
5. Okay, again, when we multiply radical 5 times radical 5, we get radical 25, which is a perfect square, and the square root of that is 5. Okay? Now, I'm going to give you, maybe I don't have to give you any help. What are we going to do now to simplify this? We have 3 different denominators. What do we do?
Find a common denominator.
Great. And we're going to call that the least common denominator. And what is it?
30.
30. Okay, the least common denominator is 30. Great. Now that we have the least common denominator, what are we going to do with it?
Multiply it to everything.
Okay, so you'll know.
Brackets around it.
Okay, since they're different, let's just do them separately at first. Okay? What do you multiply 2 by to get 30?
15.
15. So we're going to be multiplying this whole fraction by 15. Okay? What do we multiply 3 by to get 30?
10.
10. So we'll multiply this by 10. What about here?
6.
6. Okay? So we're multiplying 15 times radical 3, which gives us what?
15 radical 3.
Right. Stays that. 15 radical 3. And this becomes 30, right?
30.
Okay. 10 times radical 3 gives us what?
10 times radical 3.
10 times radical 3. And then 10 times 3 gives us?
30.
30. Minus 6 times radical 5.
6 times radical 5.
And 6 times 5?
30.
30. Now, can we do any combining here? You can combine radicals when the radicands are the same. And here we have a radical 3, and there we have a radical 3. So when we combine, what do we get?
25 radical 3.
25 radical 3 over
30.
30. And then let me just bring this over. Minus 6. Can I add that?
No,
Why not?
because they're different.
What's different?
The 5 and the 3.
Okay, the radicands have to be the same. Great. Okay, over 30. Now, is that the answer?
Yeah, but it's just.
Is that
all
the
over.
answer in simply? We're going to simplify this. Have we simplified that as much as we can?
Yeah. That's my answer.
Oh, that's your answer.
Yes, that's the answer to that.
Wait a minute, Chrissy. Is there a common factor in 25 and 30?
Yeah.
What is
You
it?
can put 5 into both.
Thank you. So we can divide 5 into this and 5 into that. And so what does that give us as an answer? Oops. 5 into 30 goes 6. Okay, so what does that give us as an answer?
5 radical 3.
5 radical 3 over 6 minus, can we simplify this? What's the common factor there, Chrissy?
6 can go into 30.
Can 6 go in, does 6 divide evenly into 30 with a 0 remainder?
Yeah.
Okay, so 6 divides into itself once, 6 divides into 30 how many times?
5.
5, and that becomes radical
5.
over 5. Is that our final answer? Can we do something else?
No.
Why not? Because you don't want me to, or because we really can't?
Because we really can't.
Why
Because
not?
5 can't go into 6 evenly.
Okay.
You can't do nothing with radical 3 and radical 5.
Why not?
Because they different.
Thank you. I'm checking you. Okay, so this is our final. But see, Chrissy, I had to check you because here you told me we were finished and you weren't right.
Well, my teacher told me it was right, so.
Excuse me, we're not talking about that. But
Okay.
this is our final answer. Will you read it for us, dear? Will you read us the
5
answer?
radical 3
Okay.
over 6 minus radical 5 over 5.
Excellent. Excellent. You did a great job. Thank you very much, Chrissy.
You're welcome.
Okay, bye-bye.
Bye.
What is my time? Let me see. Okay, let me go and try to at least get part way finished with Jesse's problem. Jesse called in a problem, which is a quadratic equation, and we were asked to complete the square, which is one method of solving quadratic equations. With this particular method, we're going to go through the steps. This was Jesse's problem. Negative 2x squared minus 5x minus 3 equals 0. The first step, the first thing we have to do with this quadratic in order to complete the square is to write it in standard form. And I've indicated what standard form is. Standard form is the square term, which is a quadratic term, and the linear term, which in this instance is x, equal to the constant term, which is a term that does not have a variable. And so this is the form we're going to put Jesse's problem in. So we're doing the quadratic term, negative 2x squared, minus 5x, equals the constant term. So we're going to be adding 3 to both sides, so the sign here is going to change and it's going to be a positive 3. At that point, we have put it in standard form. The first step of standard form. Let's go back and look at the standard form. You'll notice in the standard form there is a numerical coefficient of 1 here. So here we have a numerical coefficient of 2, so we're going to have to get rid of that 2. So the next step is to divide through each of our terms by negative 2. So after dividing, we have x squared. You'll notice the numerical coefficient of the quadratic term is now 1, plus 5 halves x equals negative 3 halves. Now at this point, it's in standard form, and we're now ready to go to the next step. The next step tells us there are several things involved in this next step. We're going to be adding the square of 1/2 the coefficient of the linear term to both sides. So first of all, we're going to have to take half of that coefficient. This is the coefficient that we're concentrating on. So let me move it over here. We're going to take half of 5 halves, which gives us 5/4. Then we're going to square 5/4, and then when we square it, we're going to have 25/16, and this is what we're going to be adding to both sides. So again, we're going to add this square of half the coefficient of the linear term to both sides of our equation. At this point, it's going to look like this. X squared plus 5 halves x plus that 25/16 equals negative 3 halves plus 25/16. Okay? Next thing we're going to do is simplify both sides of the equation. In simplifying, when we completed the square here with this trinomial, we made it a perfect square trinomial. So with that in mind, we have an opportunity to make this as a squared binomial. So in simplifying, I'm going to write this side as a squared binomial. I take the square root of x squared, the square root of 25/16, which is 5/4. And that's what we have, equal. Here we're going to get a common denominator of 16, which means I'm multiplying this by 8, which gives us negative 24/16 plus 25/16. And you'll notice we have a difference of 1. So when I finish simplifying this, I end up with 1/16. The next step, I understand, I'm going to have to pass it over to Robert Riesman to finish. But if you have any questions about it, call and I'll finish it with you on the telephone. Thank you. Robert.
Oh, thank you, Doris. In my remaining 4 minutes, I'm going to be doing a few problems here. This first one I have some help, but his name is Terrell. Terrell, can you hear me?
Yeah.
Okay, sounds like I can hear your whole family there. All right, can you see this problem well enough to read it on your own television screen?
Yeah.
Okay, go ahead, read it to me, Terrell.
23% of the newcomers thought there was no difference between a
Let's say thaumaturge.
thaumaturge and a prestidigitator.
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 Good.
If 3,465 people believed that there was a difference, how many newcomers were there in all?
All right, so this is a percent problem, right?
Yeah.
Okay, the way that I like to work a percent problem is using a proportion, setting up a couple fractions, one fraction equal to another fraction.
Okay.
All right? Now, when we're working with a percent problem, we always want to put 100 on the bottom of the first side. Now we can fill in other things from there. Now, do they give us 100%, or is that what we're trying to find out in this problem?
That's what we're going to find out.
Exactly. So we're going to put our x right there. Now, 23% of the newcomers thought there was no difference. So, Terrell, if 23% thought there was no difference, what percent thought there was a difference?
77%.
Exactly. So 77. And why do we have to find the 77%? Because it's 3,465 people believe that there was a difference. So that 77% represents that 3,465 people. Do you follow that?
Yeah.
Okay, great. So over here we'll put 3,465. All right, now, can you tell me what we do from this point, Terrell?
Cross multiply.
Very good. So we write it as an equation, right?
Yeah.
All right, let me pull up a chair here. So we have 77x equals, now what do I write?
3,465.
Okay, I'm going to put the 100 first and then put 3,465. All right. Now, Terrell, did you work this problem out ahead of time?
Yeah.
Okay, can you divide 77 into 3,465 for me, please?
45 times.
Okay, so 77 goes in there once and it goes in there 45 times, all right? I want to point out, too, this little technique of canceling right here. Canceling a lot of times goes a lot faster. Now, this happens to be a tough one. You might have to punch that in your calculator, which is perfectly fine. But rather than multiply it out right away, leave it unmultiplied. Then you might be able to see where some canceling takes place there. So, now multiply 45 times 100, and what do we get?
4,500.
All right, 4,500. So we know that the total number of newcomers was 4,500. Okay, that's very good. Very good, Terrell. Now, can you help me with this next problem here?
Yeah.
All right. I said it was called in by Pythagoras, who happens to be an 8th grader at some school here, but that's not really true. Actually, there was a theorem that was named in honor of this old mathematician, an old Greek guy named Pythagoras. Even though that he's been dead for a long time, we still use his little theorem. And his little theorem, well, Terrell, let's see how well you're doing in your algebra class. Can you recite the Pythagorean theorem for us?
I think I can.
Well, let's give it a try.
Of any right triangle, the sum of the hypotenuse equals the two side squares.
Well, you've got the right idea, but let's try it again. I'll say it and you repeat it after me. For any right triangle.
For any right triangle.
The square of the hypotenuse.
The square of the hypotenuse.
Is equal to the sum of the squares.
Is equal to the sum of the squares.
Of the other two sides.
Of the other two sides.
Now, if we were to write that in terms of algebra, that would mean that c squared would equal a squared plus b squared, all right? There's the square of the hypotenuse. Is equal to the sum of the squares of the other two sides. So how would we write an equation using these three letters right here and keeping old Pythagoras in mind?
5 squared.
All right. Now, which side are you calling the hypotenuse?
bottom.
Nope. The hypotenuse is always the
Longest side.
the longest side. Of these three sides, which one is the longest? The one, the 5, the 7, or the D?
So 5 squared plus D squared
All right, 5 squared plus D squared
equals 7 squared.
equals 7 squared. Okay, so 5 squared?
25.
25 plus D squared equals,
49.
say it again?
49.
49. Now what do we do?
Add
Careful.
minus 25 from both.
Excellent, excellent. Subtract 25 from both sides. Okay, good.
24.
So D squared equals
24.
24. So that means that D is going to equal
We can simplify. Hold on.
the square root of 24?
Yeah, I think we can simplify.
Can we simplify? Let's do a little prime factorization over here. 2, 12,
6.
2, 6, 2, 3. Looks like we have one pair there, right?
Yeah.
So the square root of 2 times square root of 2 will be 2. And the square root of 2 times square root of 3, all we can do is multiply that back. Terrell, do you know the name for that little sign right there?
Radical.
It's the radical sign. That's right. A lot of people call it a square root sign, and that's perfectly fine. But the proper name for it is the radical sign. Do you know what we call that number underneath the radical sign?
Radicand.
Oh, the radicand. The radicand. You have a good background. Now, Terrell, you want to help me with this next problem?
Okay.
All right. Now, I don't know as if you've gotten this far yet, but all it is basically, we have to solve this. Can you see that it's written in the form of ax squared plus bx plus c equals 0? You see that it's written in that form? Notice that there's an x squared here, an x here, and then a constant term right there.
Yeah.
All right. Now what we're going to do is we're going to pull out this a, this b, and this c, and then we're going to plug it into the quadratic formula. All right? Now I'll tell you what the quadratic formula is. I'm not going to ask you to know that. I'll tell you what it is. But you can help me do the substitution. You can help me do the evaluation, all right?
Okay.
All right. So now the a here will be everything that's not the x squared. So a is going to equal 2 radical 2. All right? The b, can you see what the b would be? What would be the b?
3 radical 3.
The b would just be the 3. Okay? It would be the term in front of the x.
Okay.
All right? Now what would be the c?
Just radical 2.
It would be negative radical 2. We need the sign.
Okay.
Okay. Now I'm going to give you the what's it called again? The quadratic formula. I'm going to give you the quadratic formula. Okay. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right? That's the quadratic formula. Now what this formula is going to help us to do is pick out a couple roots. Since this thing up here is not factorable, we have to use something else. Now probably you're to the point where you're doing something, you have something like this, you factor in 2 sets of parentheses, it equals 0, and at this point you can say x equals 2 and 3, just for example. Okay, you know what I'm talking about?
Yeah.
Okay, now this one is not factorable. When it is not factorable, we have to use a different method. And this method is called the we're going to utilize the quadratic equation to find those roots, all right?
Okay.
Okay, now, this is just like those evaluation problems that I'm sure you've done. Anywhere that there's a variable, I'm just going to write a little set of parentheses. Okay. Oh yeah, thank you, I forgot the c. That was very good. All right, I forgot the c in my formula. Minus 4, and then a, c. All right. And then that's all over 2a. Now, this is the b right here. What did we say the b was? 3, right. And this b squared right here, we also put a 3 there. This was an a. What did we say the a was?
2 radical 2.
2 radical 2, so I'll write that in there. All right. All right, and the c is?
Negative 2 radical.
Negative radical 2. All right. And then this a down here, I want to set a parentheses, and the a is again 2 radical 2. All right, now let's see what we can do to kind of simplify this, all right? We've got 3 minutes, so the timing should be perfect, Terrell. So this is going to be x equals negative 3 plus or minus the square root of. What is 3 squared, Terrell?
9.
9, very good. Minus. Now, we see we have a negative sign here and a negative sign here, and a negative times a negative is going to give us?
Positive.
Positive. So we know it's going to be plus, so we don't have to worry about the sign now. Now, Terrell, what's the square root of 2 times the square root of 2?
2.
2. What's 2 times 2?
4.
4. And 4 times 4?
16.
16. Excellent, excellent job. Okay, very good. So now that's all over. 2 times 2 is?
4.
So that's 4 radical 2. Terrell, you're doing really well. You follow what's going on here?
Yeah.
Okay, good. Now, we still have, I'll go down there one more time here. -3 plus or minus. What's 9 plus 16?
25.
Right. So that gives us the square root of 25, which is 5. All right. All over 4 radical 2. All right. Now I'm going to come up above and give myself a little bit more. I want to erase Pythagoras' problem here. All right. So I'm going to rewrite this up here. So if the camera will slide over a little bit. -3 plus or minus 5 over 4 radical 2. And we'll continue our problem up here. Now let's break it up into 2 pieces, Terrell, because we have this plus or minus.
Okay.
So let's see. -3 plus 5 is?
Positive 2.
Positive 2 over 4 radical 2. And then on the other side, -3 minus 5 is?
-8.
-8 over 4 radical 2. Okay? Now you see we have 2 things here that are going to equal x. But we can still continue to simplify them, all right, Terrell?
Okay.
So far, x equals both of these things. But notice that 2 will go in there once and 2 will go in there twice. All right, so we have 1 over 2 radical 2. All right, so x equals that. And 4 goes in there once and 4 goes in there twice. And here we have -2 over radical 2. But Terrell, I don't know if you know this yet, but we can't leave this alone. We can't have a radical in the denominator. We have to do something that's called rationalizing the denominator. And it's a lot like finding a common denominator when we're doing fractions. But in this case, it's called rationalizing. So we have to multiply both the top and the bottom by the square root of 2. All right? Square root of 2 divided by the square root of 2 is just 1. So we're not really changing it, are we?
No.
Okay, so the same thing on this side. The square root of 2 divided by the square root of 2, which equals 1. Now, 1 times the square root of 2 is?
Square root of 2.
Square root of 2. Square root of 2 times the square root of 2 is?
2.
2 times 2 is?
4.
4. Okay, there's our first root. Nice and sweet and proper and make any algebra teacher happy. Square root of 2 times square root of 2 is?
2.
2, so we have 2 on the bottom there. -2 times radical 2 is this. These 2's will cancel out, and we're left with, well, let's see, I'm just going to erase that. Can you see that it's going to be negative?
-2.
Negative square root of 2, right. All right, negative square root of 2. There's our 2 roots. Now, of course, if we had lots and lots and lots of time, we could plug that back in and solve it. But that's all the time that I have for my segment of math. But stay tuned for more of our 8th anniversary celebration. In the next half hour, Jose and Catherine will show you a clip from the original non-broadcast pilot. Oh, very rare footage. That was the forerunner to today's Homework Hotline show. So stay tuned now for 30 minutes of English and more with Jose and Catherine. Coming right up.
Hello, I'm Catherine Webb.
And my name's Jose Hernandez.
Welcome to the English segment of Homework Hotline. We have some very interesting material to cover on today's show.
But first, as you know, all this week we're celebrating the 8th anniversary of Homework Hotline. And as part of the celebration, we're taking a look back at some of the earliest moments on the show.
But before there was even a show, Channel 58 producer Roger Knipp put together a pilot program entitled Homework Assistance, which has never been broadcast in its entirety.
Take a look at this clip to see just how closely the 2 shows resemble each other.
School's out, and we won't be able to reach these students again until 8 o'clock tomorrow morning. Or can we? What if Channel 58 broadcast a homework assistance series using live teachers? Would promotion of such a program to reach into the homes stimulate academic achievement? It is reported to be highly successful elsewhere, including Irvine, California, and Long Island, New York, over their local cable TV systems. But how would it look in Los Angeles?
Okay, so we're ready when you are. Our phone number here is 625-6960, and we're here to help you. Let's take our first call.
Hi. I'm having a little trouble with my English homework. I still don't understand the difference between an indirect and a direct object. Could you explain that, please?
Well, Larry, this is right up your alley.
Sure.
Why don't you...
Sure. Live television teaching can be interactive, just as in the classroom. Specific homework problems could be delivered to the teachers by telephone before the program, or conversations with students could be broadcast live as the tutor attempts to explain the solution.
The action of this verb. In other words, the subject does this to this.
Yeah, I understand that part. It's the indirect that I just can't figure out, and I don't know how to use it in my papers.
Okay. Also, with the same pattern, with a subject and an action verb, you have the possibility of also having an indirect object along with your direct object. The indirect object always coming before the direct.
Oh, okay. Well, still, I just don't know how to use that when I'm writing and I'm sitting there and, you know, my sentences are all real short and everything. They don't have a whole lot of substance to them.
All right, let me give you an example. She threw Grandma from the train kiss. Okay. Now, hopefully, for Grandma's sake, we know the difference between a direct and indirect object. You have your action verb here, threw. You have your subject, she. She threw what? Or whom? What did she throw?
She threw a kiss.
Yeah, she threw a kiss.
What are we going to do today? Well, we're not going to do any indirect and direct objects, but we're still having some trouble with verbs. And today I'm going to take care of see because there are several people who are misusing seen. And we're going to do some work also with poetry. And you?
Well, fantastic. I had a question earlier about St. Patrick, so I thought that I would talk a little bit about St. Patrick and about the kind of literature that was going on at the time of St. Patrick, and also deal with a little bit of grammar.
Sounds good.